Resistive power splitters and dividers are fundamental components in RF and microwave engineering, especially when extreme bandwidth is required. Unlike reactive splitters like the Wilkinson, which rely on quarter wave lines and are thus frequency limited, resistive splitters can operate from DC to over 110 GHz. The trade-off for this bandwidth is insertion loss and poor isolation. 1. The symmetrical 3-resistor power splitter. The 3-resistor splitter is a symmetrical network where all 3 ports are interchangeable. It is designed to provide a match, Z0, at all 3 ports when the other 2 ports are terminated in Z0. Circuit analysis and derivation. To find the required resistance R for a characteristic impedance Z0, usually 50 ohm, assume port 1 is the input. Ports 2 and 3 are terminated in Z0. The input impedance Zn at port 1 must equal Z0. The network seen from port 1 consists of the series resistor R followed by 2 parallel branches. Each branch contains a series resistor R and the load Z0. From the equations, we can get R equals 1/3 of Z0. For a 50 ohm system, R equals 16.67 ohm.
Performance metrics. Insertion loss. The voltage at the internal node is Vin times Z node divided by R plus Z node. For R equals Z0 over 3, the power loss is exactly 6 dB, 3 dB from the split and 3 dB dissipated as heat. Isolation. The isolation between port 2 and port 3 is also 6 dB. This is significantly lower than a Wilkinson divider, typically greater than 20 dB. VSWR. Ideally 1-to-1 at all ports across all frequencies until parasitic elements interfere.
2. The 2-resistor power divider. The 2-resistor divider is non-symmetrical. It is primarily used in leveling loops and ratio measurements, where one port is connected to a reference detector. Circuit analysis. In this configuration, the input is connected directly to 2 resistors R, which then lead to the outputs. For the outputs to be matched to Z0 when the source is a perfect Z0 source, the resistors must be R equals Z0, 50 ohm. Input match. The input impedance is Zn equals R plus Z0 in parallel with R plus C0 equals 50 plus 50 divided by 2 equals 50 ohm. Note, while the input is matched, if you look back into an output port, the impedance match depends heavily on the source impedance. 2-resistor dividers are specifically best for applications where the source is well leveled. 3. Challenges at millimeter wave. As we move into the millimeter wave spectrum, 30 GHz to 300 GHz, the ideal resistor model fails due to parasitics. Parasitic effects. 1. Series inductance, LS. The physical length of the resistor creates inductance. At 60 GHz, even 0.1 nanohertz represents significant reactance, XL approximately 37 ohm. 2. Shunt capacitance, CP. The capacitance between the resistive film and the ground plane causes the signal to bypass the resistor at high frequencies. 3. Skin effect. At millimeter wave, current crowds the edges of the conductors, increasing effective resistance and loss.
Implementation strategies. To achieve DC to 110 GHz performance, engineers use thin film technology. Resistors are fabricated using tantalum nitride or nichrome deposited on alumina or quartz substrates. These films are extremely thin, minimizing the volume and associated parasitics. Coplanar waveguide layout. Coplanar waveguide is preferred over microstrip because it keeps the ground plane on the same surface as the signal, reducing the parasitic capacitance associated with vias to a backside ground. Flip chip or wafer level packaging. Traditional wire bonds are too inductive. Ball grid or direct solder bumps are used to maintain the 50 ohm environment into the package. 4. Comparison table. Wilkinson, reactive. 3 or 2 resistor splitter, bandwidth from DC to millimeter wave. Wilkinson, narrow bandwidth, about 1 octave. 3 or 2 resistor splitter, insertion loss 6 dB, Wilkinson 3.1 dB. Isolation, 3 resistor splitter 6 dB, 2 resistor splitter poor isolation, Wilkinson high isolation. Port match, 3 resistor splitter all ports matched, 2 resistor splitter input matched, Wilkinson all ports matched. Power handling, 3 resistor splitter low power handling, heat in resistors, 2 resistor splitter low power handling, Wilkinson power divider has high power handling. Summary for design. Use a 3-resistor splitter for general-purpose signal distribution, where you need a good match on all ports across a massive frequency range. Use a 2-resistor divider for specialized measurement setups, like source leveling or power ratio measurements. For high-power or low-loss applications, where bandwidth is not the primary concern, always default to a reactive Wilkinson splitter. Enjoying this? Smash that like button and subscribe for more RF and microwave engineering content. Drop a comment below with what you want to see next. I'm reading every single one. Thank you.